for the molecules like Li2, Be2, C2, N2, and B2, we will use this particular configuration. We have discussed it in last class. But for the diatomic molecule, for example, O2, F2, Ne2, it means for the elements which are always present in the diatomic form. So what will exactly we see that there is a change in the energy of these two orbitals. Pi 2x, pi 2py will have more energy as compared to the sigma 2pz. Okay, so this is the order, and you can take a screenshot right now so that when I start making the energy level diagram, you just know the how to do the configuration. Okay, so just take a screenshot. I'll give you 1 second only. Done?
Yes, sir.
Yes, sir.
Okay, let's start making energy level diagram. Energy level diagram. See, two things we will do simultaneously. We will calculate the bond order, and you will do the that paramagnetic, diamagnetic nature and all things. Okay. So first example what we will take the example of hydrogen. Basic example, hydrogen. So one atomic orbital of hydrogen, another atomic orbital form the molecular orbital of H2. So if I do the configuration, it is quite easy. Sigma 1s to sigma star 1s, but it contains 0 electron. So if I make the energy level diagram, see on the left side, you will show the normal configuration of the hydrogen. That is, in hydrogen, 1 electron is present, another hydrogen. This is the atomic orbital. In the mid, we will show molecular orbital. This is sigma 1s and then sigma star 1s. Join them. So what you will see, in sigma 1s we have 2 electron, while in sigma star 1s we have 0 electron. So just calculate the bond order. For the calculation of bond order, the formula we use is number of bonding electron minus number of anti-bonding electron divided by 2. So just tell me the bonding and non-bonding electron. See, the one which are not having star, they are considered as bonding. The one having the star, they are considered as anti-bonding or non-bonding, you can say. Okay. So two type of molecular orbital we have studies: bonding molecular orbital and anti-bonding molecular orbital. So in case of H2, what will happen? Number of bonding electron are 2, which are present here. Okay. And a number of anti-bonding electron is 0 divided by 2, that is equals to 2 upon 2, which is equals to 1. So it means we know that there is one bond between the hydrogen and hydrogen atom. Clear this much?
Yes,
Any
sir.
doubt in this? Okay. See, we have to look the atomic or number of bonding electrons and number of anti-bonding electron. See, if pairing is there, in the last class I told you, if pairing is there, then it is considered as paramagnetic or diamagnetic. See, remember one thing, writing here. Paired electron is, if paired electrons are present, the compound is considered as diamagnetic. If unpaired electrons is present, the compound will considered as paramagnetic. I have told this thing earlier. Paramagnetic are compound which attract by the magnetic field, while the diamagnetic are the compound which get repelled by the magnetic field. So in case of hydrogen, is it paramagnetic or diamagnetic? Speak it up. See the electrons in sigma 1s and sigma 2s. Are they paired or unpaired?
Paired, sir.
So if they are paired, it means they are hydrogen and
Diamagnetic.
diamagnetic. Okay, very good. Let's take another example. Now I'm talking about H2 plus. Okay, what is the configuration of H2 plus? Plus means one electron is donated. So it will be sigma 1s, sigma star 1s, sigma 1s have one electron. Okay, so if I'll make the energy level diagram, it will be hydrogen on one side, H positive on one side, and in the mid we have H2 plus of sigma 1s, sigma star 1s. Now when you'll see this particular thing, what will happen? Start filling the electron. In hydrogen, one electron is there, while in case of H positive, no hydrogen is there, while in case of sigma 1s, one hydrogen is there. So just calculate the bond order. Bond order will be equals to bonding electron is 1, anti-bonding electron is 0, divided by 2. It will be equals to 1 upon 2. It means half. It is not paired. And if it is not paired, the compound is paramagnetic or diamagnetic?
Paramagnetic.
Very good. The compound will be considered as paramagnetic compound. Okay. One more example. He2. Configuration of He2. See, helium. Atomic number 2. 1s2. 1s2. Well, if 1s of this will combine with the 1s of this helium, they will form the molecular orbital. And the molecular orbital is He2. That will be sigma 1s2, sigma star 1s2. Sigma 1s2, sigma star 1s2. Let's start making the molecular orbital diagram. So this is one helium having 2 electron in 1s, another helium in 1s, we have 2 electron, then sigma 1s, then sigma star 1s. Join them. See, in 1s we have 2 electron, in 2s we have, in sigma star 1s we have 2 electrons. So when we'll calculate the bond order will be 2 minus 2 upon 2. It will be 0. So the bond order between He2 is 0. It means no bond is present. So you can say that He2 don't exist. Why don't exist? Because the bond order is 0. Clear?
Yes, sir.
What about He2 positive? Configuration will be sigma 1s2, sigma star 1s1. Bond order, just directly calculate the bond order. Don't need to make the diagram.
After 1/2.
Bond order will be half. So again, the compound will be considered as
Paramagnetic.
Paramagnetic.
very good. Okay, let's bond order of calculate the bond order of Li2. Configuration of Li. Atomic number of Li is 3. Li2. So it means double. 3 to the 6. So sigma 1s, sigma star 1s, sigma 2s. 2, 2, and 2. And sigma star 2s will be 0. Okay. So first, if I'll make the diagram, Li on the left side. Okay, now we have to make 2 orbitals now. See, we have 1s and 2s both. So this is 1s, 1s, this is sigma 1s, This is sigma star 1s, then sigma 2s, then sigma star 2s, then 2s orbital, 2s orbital. This is one lithium and this is another lithium. Okay, now fill up the electrons. Li, normal configuration 1s2, 2s1. Li, again 1s2, 2s1. Okay, so let's fill in 1s. We have 2 electrons. In 1s, we have 2 electrons. In 2s1, 1 electron, 1 electron. In case of sigma 1s, we have 2 electron, then 2 electron, then 2 electron. While in the case of sigma star 1s, we don't have anything. This is the increasing order of the energy. Now tell me the bond order.
2, sir.
Bond order. Okay, let's check. Number bonding will be 4. Anti-bonding is 2 divided by 2. That is 2 upon 2. I'm having different this order, or you are having different bond order. 2 and 2. The bond order is 1. See what we have. We have this bonding, this is bonding, this is anti-bonding, and this is empty. So 2 plus 2, 4, minus 2. Okay. But now tell me, is this paramagnetic, diamagnetic? Yes, fast. See, you have to see in the mid only, not left and right. You don't have to see 1s and 2s. You only have to see bonding and anti-bonding. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. See, and now in sigma 1s, sigma star 1s, sigma 2s, all the electrons are paired. If all the electrons are paired, nature will be
Diamagnetic.
Diamagnetic.
diamagnetic. Very good. Okay, let's go for the another example, just because we need to move further. Now let's talk with the example of N2, nitrogen. Okay, let's start doing the configuration. Okay, normal nitrogen atom. Fast configuration. Atomic number of nitrogen.
7, sir.
7.
So just do a configuration 1s2, 2s2, 2p,
3.
3. 1s2, 2s2, 2p, 3. Again, next N2. So if one nitrogen is having 7 electrons, it means N2 molecule will have how many electrons?
14 electron.
14 electrons.
Okay, just start doing the configuration. Sigma 1s, 2. Sigma star 1s2. Sigma 2s2. Sigma star 2s2. Then, which
Pi.
configuration? Yeah, pi to px is equals to pi to p
Y.
y. 2 electrons. How many electrons are filled now? 12.
Pi 2 PZ. Pi PZ.
Pi pz. Pi pz. 2pz don't form pi bond. It forms sigma bond. It will be sigma 2pz. Then 2 electron. Then pi star 2px is equals to pi star 2py. This is empty. So you'll write 0, 0. Then sigma star 2pz. It will again contain 0. So this is the configuration of N2 molecule. Okay. Now let's make the energy level diagram. So from the base, I need to make it. Okay, this is sigma 1s. This is sigma star 1s. This is 1s orbital. This is 1s orbital. Combine them. See this. Can I make this vertically? If you can see, this is sigma 1s, this is sigma star 1s, this is 1s, this is 1s. Now fill up the electron. In 1s we have 2 electron, in 1s we have 2 electron, in sigma star 1s and sigma 1s we have 2 electrons. Let's move forward for the sigma 2s, then sigma star 2s, then 2s, then 2s. Now in 2s molecule they are again fully filled. In sigma 2s we have full electrons, sigma star 2s we have filled electrons. Now let's move for the pi to px equals to pi to py. So this pi to px and pi to py have approximately equal energy. Then we'll move for the sigma to p z. Then we'll go for the pi star to px is equals to pi star to py. Then sigma to p, sigma star to pz. In the mid, we know that we have 3 orbital of p, and this is the increasing order of energy. Join all of them with the p orbital. And now let's start filling. In p orbital, we have 3 electrons. I'll fill 3 electrons in each nitrogen atom. Now in the mid, pi to px and pi to py, we have 2 electrons. Then sigma to pz, we have 2 electrons. Then pi to px is equals to pi star to py is empty. Then sigma star to pz is again empty. Now in this case, just calculate the bond order.
3, sir.
Bond order will be 3. See, for calculating the bond order, number of bonding electron are,
10.
number of bonding electrons are
10.
12. Let me check. 2, 4, 5, 6, 7, 8, 9, 10.
10 only, sir.
I think it's 10. And 4, you can see anti-bonding. See, 2, 4, 5, 6, 7, 8, 9, 10. These are sigma. These are that bonding. And I'm mentioning anti-bonding with green. See, anti-bonding, anti-bonding. So it will be 6 or directly 10 bonding minus 4 anti-bonding divided by 2, that is equal to 6 upon 2, which is
3,
equal
sir.
to 3. So
3.
N triple bond N. Clear this thing?
Yes, sir. Diamagnetic.
Yeah, very good. That is diamagnetic. This is diamagnetic in nature. Okay. Next, let's take one more example. And now I'm taking example of O2 molecule. In the case of O2 molecule, sigma 2pz will come first, then will followed by the pi 2px equals to pi 2py. So in case of oxygen atom, configuration is first sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then sigma 2pz2, pi 2px is equals to pi 2py 2. Then sigma star, not sigma star, pi star to px equals to pi star to py. Then sigma star to pz. Now let's start filling the electrons. I've filled approximately, I think, 10 to 12 electrons. How many electrons are present in oxygen?
8.
8, sir.
How much?
8,
8.
sir.
But in O2 molecule, I'm asking.
16.
16.
16 electron we have to fill. Okay. So Just start filling in. 2 to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Sir, for
And
pi,
15.
pi star, we should 1.
1, 1. Yeah, very good. We will give pi star 1 electron, pi star 2py, 1, 1 electron. So let's make, see, sigma 1s is sigma star, sigma 1s to sigma star 1s to sigma 2s and sigma star 2s. They are same. So I'm directly making the pi 2px equals to pi 2py. Can you make them by your own? Lower orbitals. Okay, I'll
Can
make.
you repeat the question once again?
I said sigma 1s, sigma star 1s, pi sigma star 2s and sigma star 2s2. They are the same as we have done
Yes,
this.
sir.
So I don't think that I need to make this again. This thing is same. Okay, just see if you have confusion. This is sigma 1s. This is sigma star 1s. 1s orbital, 1s orbital. Then let's go for joining them. Sigma 2s, then sigma star 2s, then 2s orbital, then 2s orbital. Let's join them. Then now sigma 2 pz will fill first, then followed by the pi 2 px is equals to pi 2 py, then pi star 2 px is equals to pi star 2 py, then sigma star 2 pz. In the mid we have 3 orbital, in the mid we have 3 orbital. Just join all of them. This is the increasing order of energy. Now start filling up the electrons. Normal configuration of oxygen. Pass 1s2, 2s2, 2p,
4.
4. Very good. So one oxygen, 1s2, 2s2, 2p. According to Hund rule, first we'll fill the single electron, then followed by the pairing. Same goes on this side. 1s2, 2s2, single electron, the p, then followed by the pairing. Okay. So this is 2p, this is 2p. Now followed in the filled up the bonding and the anti-bonding. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz, pi star 2px is equals, pi 2px equals to pi 2py, then 1 electron in the pi star 2px and pi star 2py. According to the Hund rule, we have to fill first 1 electron in the each orbital so that we can get the symmetry. Okay, now calculate the bond order.
2, sir.
Clear?
Oh, sir.
Yes.
Okay, just tell me bond order, anti-bonding electrons.
10.
Bonding 10, sir. Anti-bonding 6.
6.
Anti-bonding is
6.
6 divided by 2, that is equals to 4.2, that is equals to 2. So we have O double bond O condition.
Paramagnetic, sir.
Very good. The compound is paramagnetic in nature.
Paramagnetic.
Very good. Not coming here. The compound will be paramagnetic in nature. Very good. So now tell me, I'm giving you 1 minute only. You have to calculate the bond order of N2 positive.
3, sir.
N2 positive is 3. Positive. N2 is 3, but N2 positive. Just do configuration first. The configuration will be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, then pi 2px is equals to pi 2py, then sigma 2pz. We don't have to write the next one. Okay, in case of N2, we have 14 electrons, but in case of N2 positive, we have 13 electrons. So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 1 electron in sigma 2pz. Now there are 13 electrons. So if we'll calculate bonding, 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 and bonding. 2, 4, 5, 6, 7, 8, 9. 9. 9, yeah. Minus
5 by
2,
2.
2 means 4 upon 2, that is equals to 5 upon 2. That is, you can say 2, 1 upon 2. The bond order is 2.5, 2, 1.5. Okay, so this is the bond order. So this is the thing what you have to remember. It is not N2. Okay, now compare the bond order of O2, O2 plus, O2 minus, O2 2 minus. Now fast calculate the bond order of every molecule. I'm giving you 5 minutes because I want you to do the configuration of each. Just tell me I'm giving you 5 minutes. Okay, the time is 5:37. Okay, just take 3 minutes. Then you have 3 minutes, 5:40. Calculate the bond order of every atom. O2, O2 plus, O2 minus, O2 2 minus. Done? Okay, 2 more minutes fast. Okay, bond order of O2 is 2.
Yes,
Bond order
sir.
of O2 positive
1.5.
1.5. O2 positive
2, sir. 2.5.
2.5. Yeah,
Yes,
2 1
sir.
upon 2. Okay, O2 negative 1 upon 2. Half 1 1 upon 2. Or what
Yes.
about O2 2 negative?
3, sir.
O2 2 negative.
1.
Again, check. I think 1. Yeah.
1, sir.
So this is the bond order. So now I'm telling you two things. Bond energy is directly proportional to bond order. If bond order is more, bond energy is more. First thing. Second thing, bond length is inversely proportional to the bond order. It means if bond order is more, bond length will be short. Okay. Next, third condition. If bond order is positive, it means number of bonding electron is more than the number of anti-bonding electron. In this particular case, compound is stable. Fourth point, bond order can be in fraction. Bond order can be in fraction. Okay, now tell me, in case of O2, O2 2 positive, O2 2 negative, O2 2 negative, O2 containing 1 negative and O2 containing 2 negative. In all of this four molecule, which one will have more bond energy?
O2.
O2, sir.
O2.
Sorry, O2.
O2 plus, sir.
Sir,
O2
O2 plus.
plus.
O2 plus,
Very
sir.
good. Very good. Very good. O2 plus will have highest bond energy just because the bond order of O2 positive is more. Okay. Next, which one will have largest bond length? Biggest bond length, you can say.
Sir, O2 2 minus. 2 minus 2. O2
O2
minus.
2 minus.
2 minus 2.
Okay. And which one is more stable?
O.
O2 positive because having the highest bond order. Bond order is more, it means the stability will be more. Okay. Okay. Now I'm giving you the question and you have to answer me as fast as you can. Okay. So let me. Okay. H2, H2 positive, H2 negative. Question is arrange the following in increasing or arrange the following in. Okay, just delete arrange the following. Just tell me which one will have the highest bond length, highest bond order. Same thing. First, calculate the bond order of every atom. Okay, one more thing. Which question is which this question? The question is changed now. Question is which of the following is paramagnetic? Which of the following is diamagnetic? First, which one is paramagnetic? Yes, student.
H2.
H2 is
Second
paramagnetic.
and third, sir. Second and third.
H2 plus H2 minus, sir.
Yes,
Paramagnetic.
sir.
These two are paramagnetic.
H2 is diamagnetic.
Very good. This is diamagnetic. Very good. So let's compare more things. Okay, in case of CO, in case of CO, calculate the bond order. Can you calculate? See, configuration is sigma 1s, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then pi 2 px equals to pi 2p. Why? Okay. How many electrons are there?
14, sir, total.
14. How? In carbon we have,
6 electrons.
and in oxygen we have
8 electrons.
Eight.
so total electrons are
14.
14.
14. So start filling. Start filling. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then sigma 2 pz. 2 electrons. Okay. Calculate bond order now. 10 bonding
Minus
4
4.
anti-bonding divided by 2, that is equals to 3.
Yes.
This much is clear?
Yes, sir.
Okay. Now I was searching for some sort of trick to remember the bond order. So I got 2 tricks. You can use them, and this was quite easy. C. Use W. This was nice. See 0, 1, 2, 3, 4, 5, 6, 7, and 8. So whatever they are coming in 0, 4, 8, they will have bond order 0, 1, 3, 5, 7 having electrons, they are having the bond order 0.5, increase 1.5, 0.5. Which are the species which are having 2 or 6 electrons, they will have bond order 1. So this was the first trick. Okay. Second trick, you can use it by making a triangle. Okay. First write 14, then 13, 12, 11, 10, 9. Okay, this is too much gap. Here we have 8, 9, 10, and 11. So we'll go on the left side, we'll go downward 14, 13, 12, 11, 10, 9, 8. While on the right side, we'll increase 13, 15, then 16, then 17, then 18, then 19, then 20. So this is the maximum system to 20 electron. However, this is not possible to ask. So we'll do for this. Okay. We have calculated the bond order of N2 when having a 14 electrons. So in case of N2, the bond order was 3.
3,
So
sir.
if any of the species having the bond order 3, any of the species having the electron 14, bond order will be 3. If any of the species having the 13 or 15 electron, then the bond order will be 2.5. In this decrease 0.5, 0.5. Okay. Having the bond order, having the electron 12 or 16, then the bond order will be 2. Having the electron 11 and 17, bond order will be 1.5. Having the electron having 18 or 10 electron, bond order will be 1. If having the species having 9 or 19 electron, it means the bond order will be 0.5. If the species having the bond 8 and 20, then the bond order will be 0.
0.
Clear?
Yes, sir.
Okay. Now I'm giving the example fast. Okay. CO positive. First calculate the number of electron fast.
2.5, sir.
2.5.
The bond order will be
2.5.
2.5.
2.5.
this much simple. Now, okay, NO plus. NO plus
3,
3.
sir.
3.
3. 14 electron system.
Three.
Okay. The example is, let me see one example. Example is N2 2 positive. Bond order.
2, sir.
2, sir.
Sir, 2, sir.
So is this clear?
Yes, sir.
So you can
Yes,
use
sir.
this trick and you can answer any of the question just to get by calculating the number of electrons. The bond order will be quite easy. Okay. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. In case of superoxide ion and in case of peroxide ion. Superoxide means O2 negative. Peroxide means O2 2 negative. Which one will have larger bond length? Which one will have larger bond length? Fast.
O2
Calculate the
negative.
bond order first. Bond order of O2 negative.
1/2.
1 by 2. O2 have 16 electron. Minus sign between 17. 17 electron will have 1.5. That is 1 upon 2. Okay. O2 2 negative. 16 electron plus 2. 18 electron system is 18 electron system. Bond order will be 1.
1, sir.
And we have learned that bond order is inversely proportional to the bond length. Now tell me, which one have the highest bond length? Larger bond
O2
length.
2 minus, sir. O2 2 minus.
O, huh? Superoxide or peroxide?
Peroxide.
Perox.
Peroxide will have higher bond length. Am I right?
Yes, sir.
Yes, sir.
What happened? Okay. So this was only in this particular chapter. Now we have finished the main topics, all the main topics, whatever is present in this particular chapter. I will forward this PDF also in your with the sir, and he will provide you. And we have done a lot of examples. Just do practice for everything. And if you have any doubt, you can ask me. First, go through this, okay, and make a schedule in such a way that you can revise this particular chapter at least half an hour daily. At least half an hour daily. If you'll give 2 to 3 theories daily, you'll complete it very easily. So this is a quite easy chapter, but quite, you can say, not you can say easily, like a systematic chapter. Like one theory failed, another theory came, then you have to do again. Okay, so repeat telecast, you can say, of VBT in VSTPR theory, some of the postulate of VSTPR theory into the MOT. So we have such things. So just I know there's a lot in this particular chapter. Like we have started approximately 1 week ago, and we have done this particular chapter today. So it means this chapter have a quite good weightage. But the question is not that much tough. Okay. So probably this Saturday you'll have a test of this particular chapter. Just go through this particular chapter, and from now onwards, from the next class, I'll start with the organic. Okay. So whatever you have learned in class 10th, at least that much organic, just revise. What is alkane, what is alkene, what is alkyne, and what are saturated compound, what are unsaturated compound. So just go through these things. Okay. Apart from that, just do the practice questions. Most of the questions Just go for the past year. And also, we have book. Just go through the book. We have certain examples given in the book. Most of the comparison, and you can say arranging them into different things. So it's quite easy. So make a schedule in such a way that you can complete it as soon as possible, so that organic will take. I'll tell you one thing: the organic will take approximately 1 month. That's a quite big chapter, organic, and the concepts are a lot. So if you'll leave this particular chapter and directly consider that organic, then let me tell you one thing: this chapter will be fade from your mind. Just revise it again and again. So I'll give you some questions today. We have practiced a lot of question today, and I'll give you one more question last for today, and then we'll be done. Okay. Remember one thing: bond order is directly proportional to the stability also. Bond order is directly proportional to the stability also. So I'm giving you some question and tell me the answer. Let me search for it. In case of CN negative, okay, in these two species, calculate bond order and tell which have higher bond energy, higher bond length, higher stability. Fast.
CN minus.
CN minus bond. First, tell me the bond order. CN bond order and CN minus bond order. CN bond order is CN bond order. Carbon 6, nitrogen 7, 13 system. 13 system bond order. For the 13 system, bond order is 2.5.
2.5.
Okay, CN minus 13 plus 1, 14. For 14, the bond order is 3. Now tell me, bond order is calculated. Now tell me which one have the highest bond energy.
CN minus.
CN minus.
Which one have higher bond length?
CN, sir.
CN.
CN, very good.
CN.
Which will have the highest stability?
CN minus.
Minus.
CN minus, sir.
CN minus. Very good. Now you guys are intelligent. I know you can do it. Okay. So just go through it. I'll forward this particular PDF. Revise the chapter. There is nothing tough until you revise it. Okay. First, go through the theory portion, then go for the bonding portion, then start VBT, then VSEPR, then MOT. Then at the last, go for the hydrogen bonding. And before that, just revise 3 to 4 rules. That is Pauli exclusion principle of class, this second chapter, Hund's rule. Okay, so these 2 rules at least, yeah, you must remember. Okay, that's it. From my side, I've done this particular chapter. You can ask anything in the next class. One day I'll put as a doubt class only. You will arrive, you will ask the question. If you will not ask, I'll give you some questions so that we can do them as a practice session. Only one class I'll take, and after that I'll start with the organic portion. First I'll start the organic, but later on in the mid I'll take a class for doubt of chemical bonding, so that if you have once revise it, definitely you'll have some doubts. Okay, so just revise this. Join the next class, and thank you so much for attending this class. Thank you. Have a good day. Please join the next session.